Hi everyone, my name is Barak Schoster and this is a special AWS community session about cloud infrastructure and template security. In this talk, we'll focus on common misconfigurations that might happen operating the public cloud and discuss some practical way to stop them when you're developing Terraform or CloudFormation code. A few words about myself and my background in case this is the first time we're talking. I am the CTO and co-founder of a cloud security startup named Breachroom. We were founded about a year ago with a mission to make cloud security much more simple. In Breachroom, I'm involved with a few open source projects around AWS, Terraform, and Google Cloud Security, which I either co-maintain or continuously contribute to. In my previous roles, I helped to build an unsupervised machine learning engine to detect anomalies on OS data and network telemetry. So you can find some of my previous work around those areas. If one of those topics interests you, you are more than welcome to ping me on Twitter. It's at Barak Case at Twitter. So what's on the agenda for today? We have a few interesting topics lined up for you. We'll start with some basic setting, get level playing field, and start getting acquainted with what is a cloud config and what is the anatomy of a cloud misconfig. And we'll try to solve that using two ways. One is the common way of config analysis or runtime analysis, and one is a more new approach, which is doing static analysis over your infrastructure code. Once we cover the basic concepts, I'd really like us to do a hands-on demo on a live environment, and we'll try to prevent those from happening and see how we can help our engineering team to acknowledge those common misconfigs. So let's talk about what is a cloud misconfig. A super interesting research by the talented team at Palo Alto have concluded that have scanned 200,000 open source repositories with infrastructure templates and saw that over 43% of the cloud databases are not encrypted. And 76% of the cloud workloads does not have SSH enabled. And this is a huge amount. Here are some of the common risks that might happen when operating and using a common open source infrastructure. So think about everything, every Terraform template, Kubernetes template, CloudFormation template that you found on GitHub, it might have those different issues. The most hectic one is finding hard-coded access keys on your source code repository. This might often lead to the common crypto mining attacks that we hear about on a daily basis. So let's start with asking ourselves, where do those configurations come from? I think it's clear we're all part of a movement, the agile movement, the DevOps movement, the open source community. We operate in a completely different way from what we used to a few years ago. We usually take the building blocks from the Stack Overflow or GitHub repositories, or even from the cloud providers themselves, instead of building them from scratch. This approach lets us to build super fast and scale out and focus on the customer value and the business use cases of our application, which is a good thing. The bad thing about it is that we bring bad configuration or configurations that we are not always familiar with because we didn't build it ourselves. And even if we did build it ourselves, we don't have always the knowledge of what is the best practice, how should a good infrastructure look like. So let's get practical. We are hearing more and more about those cloud misconfigs, and some of them are a result of a human error or lack of attention or lack of knowledge when we're working super fast and want to apply our business use cases. All of those issues are coming from commonly used registries. Those can be open source GitHub repositories, the Terraform registry, the cloud providers, or even a template that someone on a different team on our organization created by himself. Those are all boilerplate templates. Those are stripped from any business logic and are aimed to help us provisioning specific infrastructure with the least amount of work. The result is that we're not always familiar with where these configuration coming from. We've recently researched a set of open source Terraform registries, and we found that over time, the good thing that is happening, people are contributing more and more new Terraform modules. The thing is, as the metric of the amount of contributed Terraform modules is growing up, we're also seeing the number of misconfigured modules grow up. And this means that the public infrastructure that is available today does not have always the security and best practices in place. So what do we do? Before start building a fancy tech about it, let's talk about the process. Who owns this cloud security configuration issue? And how can we, in this process, handle those specific issues? So what we're seeing is a shift that is currently happening in various organizations, moving from security teams that are centralized and threat-oriented to decentralized responsibility model, where the infrastructure development is being done and security is being done by the cloud architects, by the software and application developers. Before this change, it really came down to developers who've gotten very used to deploy new applications inside on-premises data centers. They always had some kind of protective layer. They used to work in an air-gapped environment. They had firewalls, VPNs, routers to prevent from data coming in or leaking out. They knew they had the security team with the responsibility and keys to the kingdom to look after the security of the on-premise data center. But working on a fast-pacing cloud environment that is not air-gapped, we need to find a different solution that will enable us to secure and verify our infrastructure. So let's conclude. Developers are super awesome. They like to contribute and use open source. They are building super fast. They are using a lot of boilerplate templates they get from the internet. And they're not always aware of the end result of the configuration. So where do we start? We start with stable infrastructure. What we will do in this session, we will set up our own detection logic using open source tool. So you can use the open source community arsenal to have your own distributed security team. Let's start with runtime config analysis. We're talking about tracking all the configuration that are happening on cloud providers. Those are happening on the web console, API, or SDKs. Anything cloud provider comes over here. There are two main approaches here. You can't have one without the other. First, using event-based analysis detection capabilities. It will help us to detect bad activities. Anyone coming from SIEM background, that should be familiar. You set up a log aggregator, query it, and boom, you have a result of the bad actor. The second approach is where cloud provider become entirely different ball game from the on-premise one. With most of the cloud service provider going API first, it's been interesting to see how much detection you can do only based on API polling. Our favorite security projects are actually projects that combine the two approaches, both API polling and event-based. But using those, you can create your own CMDB and query it for drifts from best practices. Prowler is one of my personal favorites. Why is Prowler that awesome? It's highly maintained by the community. You get a lot of checks that are being executed on various enterprises and contributed back. It's super easy to deploy and it can securely run from anywhere. So it will map your critical configurations and will identify the misconfigs. The way to set up Prowler on a large-scale environment would be to install it on an ECS cluster with a scheduled trigger and using a cross-account role to query the different databases, IAM policies, compute instances, and S3 buckets, and return back the results into a remediation lambda that will take care and take an action on this specific resource. So let's do a quick demo. So I've created a demo environment with some resources with best practices. What I will try now to do is to detect two kinds of configuration errors. The first one, I will try to identify if we have any publicly accessible S3 bucket on this demo account. We found one, which is fun. Let's try another quick one. This will, so the way I'm using Prowler is I'm running it on the nearest region, which is in Europe. And I'm running, what's my, one second. And now what I will try to do is I will try to find hard-coded access keys, which is a different check than finding S3 buckets. So what I want to find, if I have a risk, any kind of risk, to crypto mining attack using hard-coded access keys. So what Prowler found is two different resources having hard-coded access keys in the user data. It usually means that they are either committed to invariant variables and are not encrypted, or are actually in the GitHub code. So we see that we have those two instances with access keys on. Let's try to decode one of those. And we see that we have this AWS access key ID that is just out there. And people can use it and for crypto mining on my account. So this is obviously a demo environment and it's not a real access key, but keep in mind that those stuff might happen. So we have this Prowler report that we can take as security engineers to our DevOps across the different teams. And what we'll usually do is a manual distribution of those tasks. We'll open Jira ticket to each and every team. But the team will then solve the issue. And it's not enough because more and more companies are moving into immutable infrastructure, meaning solving those issues on runtime on the AWS production environment will be overridden by the next execution of the infrastructure code, of the Terraform or CloudFormation code. So this type of tooling like Prowler is clearly not enough. Let's say we've remediated 400 S3 buckets that were public. What happens when we come up the next morning and find all of our configuration being overrun by our continuous deployment process? We have to move our focus from detecting those on the production environment into detecting those infrastructure changes on build time. Focus on our Terraform plans and CloudFormation drifts to find those misconfigs before they hit productions. This is why we've decided to open source Checkoff, a static analysis tool for infrastructure as code. So it has more than 100 built-in checks for CloudFormation and Terraform. And checks can be skipped, and it supports extensions, skips, and CI/CD integrations. So how would you integrate Checkoff into your architecture? So the way it would look like is you would usually do a code change to your infrastructure. Then you will have this code change scanned using a build pipeline like GitHub Action, Jenkins job, or something else. And you will have those infrastructure tests that Checkoff is executing, approving or rejecting your build, or approving or rejecting your merge request. After the merge request is approved and the infrastructure security test have passed, you can apply your Terraform or CloudFormation into your production account and see those resources successfully and securely being deployed. Let's see a quick demo. So over here I have CloudFormation file that I've created beforehand with some various resources like database and EBS template, etc. So let's execute Checkoff. It's pretty simple to install it. It's just pip install Checkoff. And to run it, I will just need to choose the directory that I'd like to run it against. Execute it against my CloudFormation directory. I see that I have one good security group that does not have SSH open to the world, but I also have an unencrypted EBS volume, which is bad, and I do have one security group that is with open SSH port to the world, and some other issues in that environment. So using Checkoff, we can scan our infrastructure template, and we can see it screams on us during the development time. It's quite familiar to what we saw previously on Prowler, but how can you take that to the next level? So what we will probably do is we would like to scan our infrastructure each time we're doing a commit or a pull request. So what I did make before this call is I created two example projects. One is a vulnerable by design Terraform project called TerraGoat, and another one is vulnerable by design CloudFormation template called CFNGoat. Please do not provision those into production. Those are should only be used for training. Those will stand up in vulnerable environment that might be used to harm your AWS account. So let's take one of those projects that I've created, and we will try to see how we can automate the detection around those. So over here, I have a Terraform directory with various resources, EC2 data, IAM, Lambdas, etc. Let's take a look on the EC2 Terraform. So what I can see in this code is that I actually have those hard-coded access keys that Prowler have shown us on the demo beforehand. So we have those resources that were provisioned on production, which is too late, but let's see if we can catch those on build time. So what I created a pre-commit hook that will run Checkoff on each and every commit, and on each and every file before pushing the change to my GitHub repository. So I have hard-coded access keys. Let's try to prevent those from arriving there. So let's take a look. I've done some changes before this talk, and I have an EC2 file that should be committed into production. Let's try to commit that. I will type in git commit -m AWS Summit demo. And what we will see is that Checkoff have failed prevented from this commit to arrive to the AWS production environment. And what we can do is just execute Checkoff each and every time on each and every commit and prevent those from arriving to our production environment. And what we will also see is somewhere here, we have like tons of issue because it's a very vulnerable project. We have this issue of unencrypted EBS volume, but also of of plain text access keys on our user data. All right, so we created a pre-commit hook that will prevent this code from arriving to production. But how does that look like on a CI system? Here's a screenshot from GitHub Action. You can actually use this action that was contributed by Chris. Thank you, Chris. and automate the same process that happens on every endpoint on your CI/CD pipeline and approve or reject each pull request before deriving this change forward. This is how it will look like. You will have a pull request open, you'll have a failed test, just like any integration or unit test that you have on your branch, and you will get a full report of Checkoff with the scan results. Checkoff, again, is completely open source. It's relatively new, but it already had more than 180,000 downloads. It's kind of battle tested across various large organizations. You're more than welcome to use it and contribute back to it. So the pre-commit hook and CI/CD pipeline allows us to acknowledge security risks much faster than before. Instead of opening JIRA tickets, we're catching the error during the development time or the pull request review time. And it creates an automatically distributed process between the security team and the engineering team. Everybody gets fast acknowledgement over the infrastructure errors and can take actions much faster than before. So what are the key takeaways from the two different approaches? One is that AWS config is mainly centralized. You get a report and you have to distribute it manually. The good thing about it is that it gives you the true visibility over your production environment. It's the true state. If someone manually changed the resource, you will know about it. It's scalable across multiple AWS accounts. It takes minutes to identify, depends on your scheduling mechanism, and it addresses the different teams of compliance, security, and SREs. As for static configuration analysis, the good thing about it is that it enables a completely distributed process. It's part of your CI/CD pipeline. It's scalable across multiple GitHub repositories. The bad thing about it, it's not production aware and not aware of the state, but it does take very small amount of time to identify the issue, and it addresses the developers which are at the end. So what do we do? Do we choose static analysis, runtime analysis? Those have different drawbacks. So the answer is we should do both. And how would that architecture look like? It's a bit more complex, but not much more. So we still have Checkoff over here to go over each commit, either pre-commit or CI/CD pull request, and run infrastructure and security tests against it. Once those security tests are being approved, we can use the deployment trigger to run Terraform or Cloudformation into our production environment. Once those resources are being provisioned, those can be scanned by a tool like Prowler on a continuous basis. And Prowler can give us the ability of querying the API, and even if someone did a manual change or a drift was detected that was not being done through the infrastructure, but by an admin or malicious actor, Prowler will alarm us and activate the remediation lambdas to prevent those from happening. So thank you everybody for staying for this session. I hope you've learned about Checkoff and you will contribute back. And if you have any questions, now would be the best time. Thank you.